Okay, my name is Jurgis Lukss, and today I'm a senior developer here in Mintos. And today I will tell you about our experience implementing contract testing with consumer-driven contracts using Pact.io. So I found about contract testing, I think some 10 years ago when I read an article and I found it quite interesting, and I thought, why aren't we doing this? And all this time I was quite naive how it works, and now I had the chance to implement it and find out how it's happening in real life. Probably it was the same article that inspired the creation of the Pact.io project. They are writing about similar topics and probably inspired themselves. So we'll start with our use case. We are implementing new microservices all the time. So usually to implement new features or to scale up our current operations. So we always are looking for ways how to migrate data from our main application to those microservices. So one of the approaches is we have where microservices receive events from the main application, and they react all to those events. Those events usually carry some sort of data, and the microservice can choose what it does with those data. It can either store it, or it can start a new process or something. But we wanted to create a common source for those events. So whenever we create new microservices, those new microservices can use already available events. So the common source, okay, that's the next. And we use RabbitMQ as a message transfer for the events. So that kind of restricts us what kind of implementations we can use. And this common source of events, like we yet do not know what microservices will be using this source in the future. So we are not sure what events we need to provide. Probably there will be more events that we have now, so we have to have it like extendable, so we can add more events in the future. And we don't know what data those new microservices might need. So we kind of expect that the first implementation we create will be like a minimal viable product, minimal viable data that our current microservices need. And we will add more data later. So we expect the message format to change in the future. And yeah, we want to prevent issues if the provider of like the common source, our main application, if it changes something in the data structure, we do not want it to be deployed to the production, so it like accidentally crashes our consumers, our microservices. So we wanted to come up with a solution that would prevent that. And yeah. And yeah, and we want we want to know we want our main application to know which consumers are actually using those events. So we have had cases where we change something in main application, and it turns out there is like some application in a chain of applications which actually uses those data we thought nobody uses. So it's one thing we also wanted to prevent, breaking something we don't know actually uses the data. So choosing the right strategy. There are multiple approaches you can define the protocol of data exchange between applications, we can use contract-driven design. That's the usual approach, or we can use consumer-driven contracts. In a contract-driven design service, we developed the contract beforehand. We defined what will be the schema of our message. We publish it, and so other consumers can use the schema and develop their application against that schema. In a consumer-driven approach, consumers themselves define what they will need. So in our cases, our microservices define what events they want to receive, what data they want to receive in those events. And then we have to implement the provider. In our case, it's a main application to provide those messages. So we chose to use consumer-driven contracts by contract testing with Pact.io. Here is like our considerations we used to decide to use either the CDD or CDC approach. So CDD is the common approach. I'm more familiar with Swagger. That's something I used. I think everybody knows what's Swagger. So Async API is for asynchronous messaging. The pros of CDD is that the contract is predefined. So we already, at the start of the project, we know what will be the schema. So we can define it. We have a nice, beautiful documentation in Swagger where everybody can test it, see it, and develop against it. But like teams can work independently. Once the schema is defined, everybody can look at the schema and make their application expecting provider of the data to provide messages according to the schema. And like Swagger, everybody knows Swagger works really well as a documentation. It's easy to browse it, easy to test it. But it's like cons, in my opinion, it's like it's harder to predict requirements beforehand. So in our case, we actually do not know what data our microservices actually will need, what we need to include in our events. So it's hard to define the schema and change it later. So that's one of the minuses of CDD. Also, I think the test cases and testing against the schema is not as comprehensive as it is in CDC. So CDC, there's a Pact.io project and Spring Cloud contracts. They ensure that changes don't break consumers. So contracts are always validated against all the latest versions of the consumers. I will show it later. But the idea is that the contract is defined by the consumer, and then the provider will verify the contract that it will be able to send those messages according to the schema. But whenever, like in our example, when we develop new microservice, we define new contracts. And then we expect the provider to implement those messages that our consumer will require. So it requires more team collaboration. We can't expect the messages to show up from thin air. So we have to go to the main application team and ask them, please implement those events according to our contract. And vice versa. If some changes in a main application breaks our contract, they won't be able to deploy their application, so they will come to us and ask what's broken, and we will have to collaborate and see how to improve, how to fix the issue. And the additional bonus is the provider, in our case it's main application, always knows who is using all the data it's providing. So it kind of prevents the case when some changes in main application can break some consumer that main application didn't know about. But at least in Pact.io case, it's not as good as documentation. It's not as beautiful as Swagger. It's not as easy to use, easier to understand. I'll show it later. And it's harder to deploy. Like in a case of Swagger, you just define this schema, do some tests against it, and it's done. Here you have to implement all, everything has to be actually automated to work properly, and it takes time and it takes effort from DevOps guys and developers. In a consumer-driven contracts, CDC expects you to start by writing consumer tests. So tests are written by the consumers. In our case, it's microservices that will use data from the main application. The consumer tests will generate the contract. Contract is a document that defines what kind of messages our consumer expects to receive. It includes also the examples of the messages. So those are real messages that we can test against. So the provider will have to provide specifically that message that is defined in the contract. So later we write provider tests for those contracts, and the consumer can only be deployed after the provider tests are implemented and verified. So consumer can't be run, the new version of the consumer can't be run until the provider is providing the data it expects. And provider should not be deployed, new provider version can't be deployed if it breaks any of the contracts. So we have to prevent that as well. And that means that all the communication must be backwards compatible. So at one time we might not have the latest version of the contract of consumer deployed. So provider still, like consumer, still has to be able to consume the old version of the message. And for it all to work, it has to be automatically integrated in your CI/CD pipeline. In our case, the tests on the provider side are included in our overall test suite. So if you implement something that you don't think actually interacts with the stuff we send as events to our microservices, but actually your implementation breaks something in the data structures, it will fail the test. So you won't be able to deploy your changes because CI phase will fail, and will fail because contract tests will not be verified. And you will see that there's an issue. So at the start, contracts can be stored in S3 bucket, but Pact.io project provides Pact Broker, and Pact Broker is preferable, and I will explain why. But actually, like the contract itself is just a JSON file, so you can easily save it as a file in shareable location. It can be S3 bucket, it can be a network folder or something. But then comes the verification and versioning, and that's the problem. That's hard to implement just with data storage. So contract versioning is a problem, and that's the first issue we found when implementing contract testing, how to version all the contracts. So the simplest case is there's a consumer has its own version, and provider has its own version. Like in this case, it says consumer version 0.10, provider version 1.0.0. So consumer creates consumer tests and creates its first contract. The contract actually will not verify against the provider version, latest provider version, because provider has not yet implemented the functionality that will validate the contract. So we implement a new version for the provider that can implement the current contract. We deploy the version, and then we can deploy consumer as well. Then there is a new version for the microservice. This version actually doesn't change anything in the contract. If nothing in contract is changed, it automatically gets verified. It doesn't have to go the verification process again. But then there is a new version 0.2, yeah, and that creates a new contract. The problem is now that we have two contracts between the same provider and consumer. So provider has to know which of the contracts it has to validate for it to know that something is broken. So naturally, the old version 2.0, will not work with a new contract because it's not implemented the new functionality. So if our provider would just check the latest contract file available from the consumer, it will just fail, and even if the version by the consumer is not deployed. So it will have to wait for the new version which implements the functionality, and then you can verify it. And that is like an issue that the Pact Broker solves. One of the issues. So other issues, the Pact Broker, Pact Broker is a standalone service or application. You can get it as a Docker image. You can deploy it as on a virtual machine, and it will work, and you can send the contracts to it just as you would have sent it to S3. So consumers store the contracts automatically, publish them to Pact Broker. They can add tags to their versions, and that's one of the important features of the Pact Broker, that the versions can be tagged. Then providers can query Pact Broker for contracts, so it doesn't have to look into the folder. It can just ask Pact Broker for the contracts, and the Pact Broker will send the contracts to the consumer. And providers will receive all those contracts, and it will try to verify them. If the verification is successful or unsuccessful, it will publish those results to the Pact Broker, and Pact Broker will remember which version of the consumer is verified by which version of provider. So also Pact Broker will not allow to store different contracts with the same version number. So if you accidentally change the contract but don't change the version number, it will not allow you to save it, so you won't be able to break existing contracts. When contract is published, it should be unchanged. It's one-time thing. The Pact Broker will record which provider version has verified which contract. We use git commit hash number as the version number. That's the recommended approach by Pact.io. At start, we tried to use different version numbers, but we ran into problems, so we used the recommended approach. And continuous deployment process can then check if current version being deployed, is it verified on Pact Broker. So there's a can I deploy method. It's available as a command, or you can use as an API endpoint. You can ask this continuous deployment process can ask Pact Broker if this version is good for deployment. So has it satisfied all those contracts. So here I provided some examples how Pact Broker UI looks like. Here are our contracts. It's for multiple services. As Mintos Marketplace is mostly our provider, so all the services integrate with that one. When you press this button, you get a matrix of all the versions. I'll show it later. Also, you can create webhooks, so whenever a new version comes in, it can trigger some sort of like build process or something if you need something. And that's the webhook status is displayed here as well. So when you open the matrix, here you can query different consumer versions and provider versions, see when they are verified. If you click on the verification data, you can see the verification result. So in our case, here is the consumer version that is currently verified against this provider version. As you can see, our provider versions are coming in constantly, like it's every 5 minutes, because we run this contract tests on every CI process that's been merged in a master branch. And they all are verified against the latest consumer version for this service. And the blue ones, those are the tags. They are important, and I'll explain later. And you also can get this network graphs. For this example, it's smaller, it can get bigger. So you can see like our Mintos Marketplace integrates with those services, and there is an internal service that integrates with microservice number 3. So it's not directly integrating with Mintos Marketplace. That's all you can get from Pact Broker. I would want something more from this, but that's what they provide. So yeah, this is Mintos Marketplace. Those are the microservices it integrates with. So here's an example how a contract looks like. The contract is just a JSON file. It has a specific specification. It's Pact.io specification, so they have their own standard. Here's if you can see, but that's the consumer. Consumer is our microservice. Here's the provider. Provider in our case is Mintos Marketplace. Here is the test case, like the message. Each contract can contain many messages. Contract is just between the consumer and the provider, so it can have a lot of messages. And the message contains like a specific example of a message. It's not a schema, it's not like a validation format, it's just a message. And then there is provider states. Provider states I'll explain later, but that's one of the features that allows you to define data necessary for the test to be executed. And here's the name of the test. The test name or description in this case, it's called, it has to be unique. So Pact.io comes with their own terminology, just to mess with you. So the Pact is a contract between consumer and provider. They don't call it contract, they call it Pact. Participant is a participant in the contract, so it's either consumer or provider. That's also just to mess with you, like all the commands use the name participant, and if you want to write participant, it will not work, so it's participant. So yeah, provider states, as I mentioned, for each contract test case, you can like define provider states. That's like in every integration test, you define what's given. So it's given, we have such state, and such state should generate message we expect. And tags are messages you can attach to the contract version. You can later filter those contracts using those tags. So we use branch name as the tag, so we can later find just the versions that are currently being worked on. Environment, it's similar to tags. It can be, you can define that the contract is currently in production, or is it in testing or in staging. Branch, that's a new feature. They recommend using branch instead of tag, but branch doesn't work in PHP, so we didn't use it. And work in progress pact. You can mark contracts as a work in progress, so they don't get tested against, but there are cases that you need to test against them. So you can mark them as such. We didn't use it, but that's a feature. So in the end, conclusions and learnings, we spent a lot of time implementing this, and it was not as easy as it seemed at the start. One of the features why we chose to implement the contract testing using Pact.io as a solution was Spring, Java Spring contract tests. Java Spring contract tests work usually just with Java. They have some integration with other languages, but Pact.io usually supports most of the languages. We used many languages in our microservice. We do not specify what language we use in every microservice, so microservice can, the team developing microservice can choose whatever language they want. So we don't want to restrict them with a contract testing environment that expects just the Java. So I recommend to use contract testing if you have 2 or more teams sharing data between applications. Usually you would go with just the schema defined as a Swagger, but if you use contract testing, you can also provide those message examples. You can use those examples later in your tests. My recommendation would be to use the exact message as part of your test case. So you just run it through all your internal systems as if you really received the message or submitted it. And one issue we run into was you have to use the correct serializer on deserializer for the messages. If you just use standard JSON serializer, it might not serialize the data exactly as your system will do. So our tests will be green, everything will be fine, but later you'll find out that in the production they use different serializer, and the message does not look exactly like it looked in the tests. So all the contract testing goes to waste. You can't use random dates, random numbers, dates in the messages. Messages always has to, the contract doesn't change, so contract always has to be the same. So you always have, the test case has to always be exactly, contain exactly the same data. So you can't use random numbers. That's one of the limitations. You have to keep them in mind. Usually it takes some effort to get specific data, for example, in your message. Yeah, as I said, Pact.io contract testing framework is available in most languages. So that's not really a problem, but the problem is that the implementation is not the same in all the languages. In our example, we found out that PHP version doesn't support the latest specification, latest features, so we had to adapt what is available and how to implement it. In my opinion, contract tests gives a better overview about the system interdependence. So especially in our case, when we have a single source of the events, we don't know who will use those events, how it's going to grow. We expect there will be more microservices that will use those data. Not always like it will be the same team implementing all the messages, all the events, and all the microservices. So it's good that there is like overview how all those messages are how all those microservices are interacting with them, and it's strictly defined and it's tested and it's valid. So yeah, in our case, we found out that the PHP integration was not as good as in Java. So we had to do more work with PHP implementation. I don't know about other implementations, but that's also an issue. Other issue is with Pact.io is that it's an old project. It's a project made 10 years ago. So there's a lot of changes that have happened between those years. And one of the things is that initially it was developed for standard HTTP endpoints. So it did not use message communication. Now they have message communication implemented. But it's not like it goes through the same processes that were previously defined for the HTTP implementation. So I don't think it's the best solution, but it works. Yeah, it could be better. Yeah, and other issue we found out was that deploying new version of the contract is a complicated process. So there are multiple parts involved. You have to have the current contract. It has to be verified. Then you have to make the new contract, but you must make sure that it's not being tested against by the production version of your application. It has to be just tested against your latest development version of your application. So it takes a lot of different like tags and filters to make sure everything works. And if it's not automated, it's easy to break the system. Like in our case, we use contract testing in our main continuous integration test suite. So if we break contract tests, we break all our other deployments. So nobody can deploy if somebody messes up deployment process of the contract. So that's why it needs to be automated. So the process is strict and you can't mess something up. And yeah, as we found out, not all issues can be caught with contract tests. Like that's the same with any tests. You can not provide specific. Maybe you forgot to provide specific cases for the tests. You didn't provide the case that actually broke your system. So it is like it gives more sense of security that you have those contract tests, that the communication between the services is being tested, not just with integration tests, but with the contract tests. But also, you can't be sure that nothing actually can be broken. As the case with the serializers, deserializers, like we had all our contract tests were green, verified, and then we found out that our serializer was not correct and it didn't work. So also, whenever there are multiple services inside the same team communicating, I don't see big use case to use contract tests. It just makes it a bit complicated. So I find it useful if there are multiple teams. They have to communicate about data exchange formats and messages they want to exchange between them. But if it's just one team internally, I don't see there's use for contract tests. And yeah, the main issue was the Pact.io documentation is really confusing. So it's an old project. It's 10 years old. There's a lot of approaches they have tried, a lot of different implementations they have made, and they have everything is documented there. So you can find everything. But when you want to find the best solution, best approach, like the latest recommended implementation, you can't find it. There are a lot of, you can do it like that, you can do it like that, you can try this, you can try that, but there is no one specific solution like do it like this and this will work. So yeah, that's at first when you look at documentation, you see, wow, there's a lot of documentation. You can find everything there, but when you need to implement something and you run into issues, the documentation is not helping. So that's it. So maybe some questions. Yes.
Well, one. Hey, I don't understand how you handle situation when you have like multiple consumers for one event, or each consumer should provide one contract for itself, or they can share a contract.
No, actually you will have to make a contract for each consumer. Yeah.
So basically, if producer produce one event, you have to like.
Yes, the producer, even if a new service is coming in, new consumer is coming up, this will be new contract, and the provider will have to implement this contract.
And the second
but actually, you can cheat and you can copy the contract, and it will verify automatically. Yeah.
And the second question: why producer should know who consumed its events?
Yeah, that's with our experience. Like there are cases when if the producer doesn't know who is consuming the events, it can think maybe this event is not necessary, like nobody uses it, we can just delete it. So when we delete it, we found out later, oh, actually somebody uses it. Oh, so if it's like, if you don't have contract tests, you delete it, and like a week later, somebody comes to you, our system broke. What happened?
Don't delete it.
Yeah, don't do it. It's like, oh, we didn't know you were actually using this.
Then don't delete it.
Yeah.
Or check Rabbit.
Yeah.
Hi, thanks.
Hi.
My question is about producer and consumer. If you talk about this paradigm, if we talk in a one company, yeah? Or it can be consumer may be a separate company, and if it that case, how we can make a security for deployment, and how integrate in a infrastructure of your company, how it's integrated.
Yeah, actually, in that case, you would have to make the Pact Broker available for the consumer or provider if it's another company. Like, actually, the provider company probably will.
So you provide a broker to your consumer, yeah?
Yeah, to your consumer, yeah.
Ah,
so
okay.
it can publish their contracts there. But there is some sort of user access management in the Pact Broker. I haven't dug into it very much, but it's not really comprehensive, so you can't have different access rights, I think, for different companies, so you have to manage it somehow.
Okay.
You have to experiment. We haven't experimented with it, so that's all I can tell.
Any questions?
Okay. No questions. Thank you.